Hello, everyone. Good evening, and welcome to today's review session. For those of you who don't know me, my name is Daniel Manasia. I am a fourth-year medical student, MD loading, class of 2025. And today we are going to be going over Jack Weston full-length practice exam number 5, and we're going to be going over the chemistry physics portion, and we're going to be doing passage number 9. So without any further ado, without taking up too much more time, I'm going to go ahead and share my screen here. And so how this is going to go, as per usual, I'm going to be reading the passage, highlighting the key pieces of information that I think are pertinent, and then I'm going to be answering the questions, and kind of going over my thought process as I answer these questions. So yeah, let's go ahead and get started. All right, so cobalt spinel based catalysts are used in environmental and electrocatalytic applications. Okay, so talking about cobalt spinel based catalysts. All right, and things I feel like we need to highlight electrocatalytic applications. Okay, looks like we'll talk about some maybe electrolysis, maybe some, yeah, electrocatalytic reactions, things like that, including N2O decomposition. Okay. So now we're talking about the electrocatalytic applications of the cobalt spinel based catalyst. Methane oxidation. Okay. Pretty cool. The oxygen evolution reaction in water electrolysis. Okay. All right, cool. An instructor demonstrated hydrogen peroxide decomposition catalyzed by cobalt spinel at varying calcination temperatures. Okay, so hydrogen peroxide decomposition. Okay, it's going to highlight that as well. All right. All right. So this compound, cobalt spinel, is catalyzed by calcining cobalt. I hope I'm saying that right. Calcining cobalt carbonate at various temperatures. Cobalt 2 nitrate is mixed with potassium carbonate. Okay. So I'm going to highlight that as well. Cobalt 2 nitrate plus potassium carbonate to precipitate cobalt 2 carbonate. Okay, cool. All right. Simple reaction. Adjusted to pH 9. Okay, pH 9 is what? Alkaline. All right, you guys know that. The resulting slurry is washed and dried to obtain the precursor powder. Heating this precursor with varying temperatures for 2 hours yields cobalt spinel samples. So this is how we're making cobalt spinel. Excuse me. All right, so how do we make cobalt spinel? Heating the precursor, all right, for 2 hours yields cobalt spinel samples. And I know it looks like I'm highlighting a lot of things this time around, but they all just look like they are important. Okay. That's why. So sometimes you highlight less with some passages might require you to highlight more. Just go based off of your knowledge, trust your instincts, and if something seems important, highlight it. Okay. At higher temperatures, producing larger crystals. Before demonstrations, this cobalt spinel materials are finely ground. Okay, cool. So figure one is cobalt spinel synthesis. And we see the potassium carbonate, we see cobalt 2 nitrate, we see precipitation at pH 9. Okay, they wash it, filter it, they dry it 60 degrees Celsius, and we get our, I guess, cobalt carbonate. Okay. Yep. All right, cool. And then, yeah, we get our cobalt spinel. Okay, cool. All right, next, a detergent solution is prepared mixing what? 10 milliliters of detergent. So if you see a volume, more times than not, you might need it for a calculation. So I'll just go ahead and highlight it here. Um, so 10 milliliters of detergent with 100 milliliters of water. Okay, all right, cool. Four 250 milliliter graduated cylinders. Okay, are filled with 10 milliliters of detergent solution and 0.25 gram samples of, okay, is that cobalt spinel? Let's see here. Uh, yep, that looks like cobalt spinel. Right? Okay, so cobalt spinel. All right, so 0.25 gram samples of cobalt spinel material. Okay, calcined at various temperatures are added using a funnel. Okay. After gentle stirring to ensure uniform suspension, excuse me, guys, 5 milliliters of 10% hydrogen peroxide is simultaneously added to all cylinders using 4 automatic pipettes. Okay. So, okay, calcined at various temperatures. Okay. Added using a funnel after gentle stirring to ensure uniform suspension. 5 milliliters, 10% hydrogen peroxide. It's simultaneously added to all cylinders. Okay. Figure 2 illustrates the foam volume. Okay, foam volume correlating with O2 release. Okay, so that was also the first thing that came to my mind. So foam volume or bubbles, usually they're talking about the amount of gas released. Okay, so correlating with oxygen release. All right, so for cobalt spinel catalyst with 0.25 gram loadings, calcined at different temperatures. Okay, so figure 2 is showing the foam volume correlating with oxygen release for cobalt spinel catalyst with 0.25 gram loadings, calcined at different temperatures. Okay, great, and that's the passage. All right, so we got two figures and we got a bunch of um, information about cobalt spinel, um, precipitation of cobalt carbonate, and yeah, how they make cobalt spinel and how they use cobalt spinel um, to how they're using cobalt spinel to with hydrogen peroxide, I guess, to release oxygen. Okay, cool. That's kind of the gist of it. All right, now question 48. Which reagent depicts the reaction that results in form formation in figure 2? Okay, so we know that figure 2, we're talking about hydrogen peroxide, right? And oxygen is being released. So oxygen is being released, hydrogen peroxide. Okay, so this is water. Okay, no, that's not the answer. Cobalt spinel plus hydrogen, no. Um, okay, C looks like the answer. And D, I don't even think we talked about D, and we're not releasing hydrogen gas. So I guess since we know that oxygen is being released, we just go for the ones that have oxygen in the product side of the equation. And um, yeah, since between the two of them that have oxygen on the product side of the react of the equation or the reaction, the balance reaction, this isn't hydrogen peroxide, this is, and we know we're using hydrogen peroxide for the experiment in figure 2. So C, that's the answer. It's pretty straightforward, pretty simple question. Okay, great. 74% of people got it right. Okay, cool. Yep, A is the electrolysis of water, B is reduction of cobalt, D is dehydration of cobalt. So yeah, C is the correct answer. Okay. That was a pretty straightforward question. If you're having trouble interpreting the questions, if you see these kinds of questions and panic, reach out to me or one of the other MIM and CAT tutors, and we'll be glad to help you out. Okay. All right, moving on. Which of the following is not an application of cobalt spinel-based catalyst described in the passage? All right, so A is electrolysis of water. Okay, so where did we see that? Um, right here. Okay, so we can literally just reel them off because they gave the applications that I guess they wanted us to know about. So A is here, electrolysis of water. B is here, N2O or NO2 decomposition, I guess. It would still count. It's still the decomposition, right? Hmm, methane oxidation, that is C. And D is what? So D is not an application to a cobalt spinel based catalyst because it's not listed here. So I see this, I see this, I see this, but not this. Okay. So it's pretty much that simple. I am 99.999% sure that this is the answer. Okay, great. But only 40% of people got it right. That's really interesting. I mean, just because it has cobalt in here. So they're asking which of the following is not an application of cobalt spinel based catalyst. So you got to refer to the passage. They literally told us cobalt spinel based catalysts are used in environmental electrocatalytic applications, including N2O decomposition. So we see a decomposition right here. Methane oxidation, that's this right here. Oxygen evolution reaction and water electrolysis, that's the first one. So just by process of elimination, okay, we know that. So this is, so the answer we chose apparently is illustrating the synthesis of cobalt spinel from cobalt 2 carbonate through calcination. Okay, it's not listed as a catalytic application of cobalt spinel, but the synthesis of cobalt spinel. Okay, so this is pretty much a simple interpretation question. Okay, so you got to read the question, you got to interpret it, and you got to know what they're asking you for. Okay, in this case, they were asking you what is what are the applications of cobalt spinel based catalysts? Okay, not how is a cobalt spinel based catalyst formed. So this is a, pretty straightforward question. You can literally eliminate the other options by just looking at the passage. Okay, and we already highlighted them. So yeah, pretty straightforward in my opinion. But again, if it didn't seem that simple, if you're still having confusion, feel free to reach out, and we'll be able to help you. Okay. All right. Moving on.